Anyways, all right, let's talk about the kind of skills required for data engineers. So we'll talk about let's try to think about like an end-to-end solution here. Let's say we're trying to build some machine learning or whatever, data applications, and you need to get data first, right? So data, let's talk about data ingestion. Here is one example of a bank, right? So bank, on the left-hand side, we'll see, different types of data collected by a bank, right? So you're depositing money, through ATM, you swipe your Visa card, right? You do, you get your home loan, mortgage, right? Car loans, you open up your investment account. So these data traditionally are, right? Operational level data will be saved in your CRM systems, your transaction databases, a lot of CSV files from finance, right? If you have legal documents, you're trying to digitize that as well. So there are structured data, unstructured data, there's semi-structured data, but traditionally data are more like ingested into operational databases that are relational databases, right? So for bank insurance companies, they definitely have their on-premise, right, operational databases. They're moving to the cloud as well, but operational databases are always important, right, for the operations of the company. On the big data side, right, or companies are talking about, building data lakes in the cloud. So a lot of the interesting applications, for example, insurance companies might be collecting your location data, driving behavior in real time, call center data, social media data, right, collected in real time, and they would like to convert the call center call logs into, voice to text, right, and they have a lot of text data, want to do text mining. So these are unstructured data. Now, the pitfalls of the relational database is that you can use it to store unstructured data, but you can't really analyze those data using SQL really well. So that's where technology such as Hadoop, Apache Spark really shines. But Hadoop is almost out of the picture because becomes outdated, right? So companies like Geotab said they're Hadoop free. And I think cloud is having a big hit on the Hadoop market, right? Because when companies can move to cloud using managed services, now it just removed the needs, of Cloudera, for example. But anyways, ingesting data, right, in real time into, messaging queues such as, Kafka or Amazon Kinesis data streams or Firehose, and allows the company to analyze data in real time as well. But this is on the data ingestion side, right? So as a data engineer, I think you need to understand how data is ingested. Actually, a lot of these can actually be automated, or I wouldn't say automated, but like there are a lot of commercial tools out there, such as, Talent, Informatica. There's also smaller players, right? That actually help companies just to integrate data from many different sources, because the company may have like more than 60, even 70 data sources. You have Google Analytics data. If your company runs Salesforce, then Salesforce or data collected into HubSpot. You obviously want to automate those data ingestion process, right? So from the source systems into the company's data lake or whatever data warehouses. So that's the data ingestion. A data engineer definitely will need to be really good with databases and also building connectors. But there are also companies, you can work with data factories in Azure as well. But there are companies that just use a commercial tool that help them to connect to many different sources and automate that process. So the data is already in the data lake or in the database somewhere. But there are also other businesses that will write their own data connectors, right? So that's something a data engineers at least need to understand. But traditionally in a large companies, this is typically done by the IT side, right? So your IT organization is going to do all of these, and data engineers more like working on the warehouse side, or when the data is in the data warehouse, you're going to do a lot of pipelines, which is the next step. So here we see the ELT, ETL, that's related to data, extraction. So ETL stands for extract, transform, and load, right? Extract means, extracting data from different source systems. It could be, data from Excel. It could be data coming from, a relational database or even a NoSQL database, right? How to extract data from different sources and put that into a data warehouse. Think of data warehouse as a more centralized, repository of data, and you have to do the data modeling. Of course, it's not as flexible as NoSQL databases, but typically a data warehouse is, a relational database. Okay, so you have a centralized place to keep all of your data, but then of course, a lot of companies will separate them in. Traditionally, they will separate them into, logically separate these, data, right? So you have marketing database, you have the risk database, your compliance database for a bank, right? So these are also called data marts, just a smaller version, right? But I think Snowflake, when Snowflake came out, is trying to, it changed a lot of things like the ways people do ETL. For example, maybe you can do ELT, just load the data into, data warehouse first and do all the heavy lifting, transformation directly in the databases on the database side. And traditionally, this can be very challenging. But by separating storage and compute, now you can have like many small data warehouses that can run on the fly to do a lot of the heavy lifting, workloads. That's pretty cool. So yeah, so that means, on the ETL, ELT side, you need to be familiar with things like BigQuery, Amazon Redshift, or, Snowflake, this kind of column-oriented database, and definitely need to be expert in tuning SQL queries, right? And understand how to, work with those databases. Now, on the data lake side, right? So, there are companies that also prefer to go with a data lake approach, right? So where they actually ingest the data into their data lake. It doesn't have to be Hadoop HDFS anymore, right? Because Spark is very flexible. It can read data from HDFS, but it can read data from Amazon S3, Google Cloud Storage, right? It can, read from blob storage as well. It can read data from NoSQL database, any kind of data sources, even from a data warehouse. So if you want to process and transform data using a data lake, so knowing Apache Spark is something very important. Not every company need Apache Spark, to be honest, but at least if you do the whatever job market analysis, you'll find like Spark is the number 4, I think number 3 or number 4 popular skills in those job postings. Okay, and of course, then we also talked about a different kind of data engineers which focus on BI side, right? So, so these are the data engineers that know how to build OLAP cubes, right? Traditionally, these are ETL or BI specialists. They could be data engineers as well. If your company has a data warehouse, right, using the Microsoft SSIS RS, you might need to build cubes, right? Because that will allow your business dashboard to run a lot faster, right? Instead of always running queries on the fly. But things are also changing a little bit because some of these databases have become really powerful. Amazon has Athena that allows you to run a lot of really large scale interactive queries on the fly. But I think building all that multi-dimensional cubes will still make sense for a lot of organizations, especially you have a ton of dimensions, like companies like eBay, right? They have thousands of dimensions, and then when you build the cubes, it's going to be massive. So storing these cubes in in a NoSQL database, will make sense. So that's why some of the open source projects, such as Apache Kylin, exists, right? Because you cannot, like, if you are going to refresh your dashboard very frequently, running some of those queries against terabytes of data is still going to be very expensive. So knowing how to build cubes, but can be useful. But just preparing data for the BI, right, analysts is part of the responsibility of data engineers in some organizations. And if you use Power BI, for example, this is Power BI dashboard, knowing DAX, how to do transformations in Power BI is, it can also be very helpful. Okay. Sorry, I think I missed something here. Now, in the data lake, space, then you can use, interactive query tools such as Presto. And the commercial version in Amazon, or the managed version in Amazon, is called Athena, right? So you don't really need to spin up any servers anymore, instances. It's almost like serverless. So you can just, when you go into Athena, you just start writing queries. But of course, you need to use Amazon Glue to build the data catalog first. Then you can run the queries. So I think it's pretty cool. But again, none of these are really hard to learn, because if you know SQL well, it's not, the constant, in terms of using it, it's not that hard. Okay, so that's why SQL is still very important for data engineers. Okay. Now, on the machine learning side, right? So Now we're moving from BI to machine learning, right? So I'm adding a box here. This is what the data scientist would focus on. Okay, let's say we're building some sort of machine learning models to predict customer churn or risk model. So the data scientist will need the data prepared for them. Like they will need the machine learning data set, or sometimes it's called a feature data set. On ML ops side, in production, these feature tables are stored in something called feature table, right? Which a lot of time is NoSQL database. So some banks, as far as I know, right? If you want to build, risk models, they may actually have thousands of features. That means, it's a flat table that has one row per customer or per client, per account, whatever, or per transaction. And then they will have like, a few thousand features. I used to work for a telecom, right? Even like 12 years ago, they had like 4,000 features in that table. So that table is pretty massive. And imagine you have like tens of millions of customers, right? So the data scientist will use that table to do feature engineering and build machine learning models. That's quite exciting. But without the data engineer to automate the data pipelines, to generate those 5,000 features, right, on a timely manner, and also need to make sure that the data quality is good, right? So, and then it will become garbage in, garbage out, right? So, so that's why data engineers a lot of times are also feeding data into the machine learning process, and that is really the key. Having good quality data is sometimes even more important than spending 2 weeks just tuning your machine learning models and deciding that, oh, your deep learning model is has 1% gain in or edge in terms of performance, but then the next day when you deploy that in production, one of the one of the key features used for model, the distribution screwed up, and then your model just performance just completely gets screwed up. So yeah, so I think data engineer is preparing data for machine learning and automate that process as well. So that's really the key here. And of course, all of these needs to be automated, right? So automation using Apache Airflow, you can use hosted Airflow services, you can use Amazon step functions. There are many different ways to automate that. I used to use Amazon data pipelines, but it doesn't seem very popular anymore, I guess. But there are more exciting tools out there that allows you to orchestrate your data pipelines, and that's pretty cool. But from the source data, right, extracting data from the source systems to load that into a data warehouse or a data lake, and then using Apache Spark or using SQL to do a lot of the transformations and generating a table that has 5,000 features. And probably before you do the model deployment, like, because when you deploy the machine learning models, you want to generate predictions on a daily basis, let's say. But sometimes it's real time, then you have to deploy that as an endpoint. But if it's not real-time based, you just want to generate prediction on a daily, weekly basis. This is actually quite common. You need to make sure that all the distributions, right, of those 5,000 columns stay the same, or the percentage of missing values, right, it is not going to be very different. So there are a lot of data quality check you need to do, and that also means you need to monitor. Once you get the response data, you need to make sure that the feedback data, let's say your company is doing surveys, whatever, or email campaigns, right, using MailChimp. So how do we download the data? Because now the MailChimp will tell you who actually clicked on those messages, right, or those emails, who viewed and who clicked. So you have to bring those data through some sort of MailChimp API back into your marketing database. That's probably what the data engineer would do as well, right? Just bringing the data back and clean that and merge that back to your customer data, so the data scientist can improve the machine learning model. So you see that data engineering or data engineers are playing important roles, like just throughout the whole process. So knowing automation, automation is also going to save your life here, because things can break anytime. You don't want to really be just wake up in the evening and your data pipeline just broke and you have to fix things, right? So yeah, so hopefully this is a good introduction of different kinds of data engineering skills required throughout some sort of data life stage. Okay, Now, data engineer also sometimes play a role in machine learning engineering. So machine learning in productions are actually, so I think the perception here is that ML in productions are mostly about machine learning, right? That's the common, I guess, misunderstanding, right? Because this is how data scientists think about machine learning. They think the machine learning code is the most important. But just, if we look at the entire whatever ecosystem or, everything you're trying to build, you need to collect data, right? Infrastructure side, you need to do all the configuration, right? Infrastructure as code, or if maybe your company use, Kubernetes, you want to deploy the machine learning model, you have to do the serving that requires data infrastructure as well, monitoring, or even sometimes when you deploy a machine learning model, it could be just Amazon Lambda function using serverless, right? So let's say you train a image class, or maybe just a very small application, but let's say the data scientist, or let's say when someone upload, or let's say Instagram or whatever application, when you upload your your picture, that becomes your your profile picture, right? But your picture might be of very sizes and quality, right? So whenever you upload the picture, the data will actually be saved in Amazon S3, right? In one of the cloud storage, but it actually triggers a Lambda function that actually just crop the image and just resize it to make it thumbnail, right? And then you have to save that in a different bucket somewhere. And so, yeah, so that could be set up as a Lambda function. And so that is also related to data as well, right? So there are a lot of small use cases here. But this is actually what it looks like, right? ML in production. It actually requires a lot of data engineering, DevOps, and machine learning engineering as well, not just data engineering, right? When you look at the code base, your machine learning code is, code base is really small. But you're going to write a lot of code for data engineering, for machine learning engineering as well, and even on the monitoring side, right? Do log analysis, maybe through Elasticsearch and Kibana. So you have to ingest a lot of the logs into Elasticsearch and analyze that, and even build some dashboard. So that's what. In some organizations, the operations team doing that, and in some organizations, it's actually engineers doing that, right? So, okay, so just to just a quick summary of the big data ecosystem. I think data engineers need to know big data for sure. So on the infrastructure side, I don't think you need to worry too much about it. It's usually the platform and infrastructure engineers and IT who's doing that. But your companies can be running in the cloud or on-prem, right? So I think a good business to be in right now is just helping companies to migrate from on-prem to the cloud. I see a lot of consulting companies do that, right? But before you can do big data, let's say you need to move all of your data from on-prem to the cloud, but it's not something that's going to happen overnight, right? So companies will still keep data and keep their on-prem infrastructure and gradually move to the cloud, right? So in the interim, they're going to have multiple systems running, they have their on-prem servers running, they'll have their cloud infrastructure running at the same time, but gradually data will be ingested into the cloud directly, right? But once you're in the cloud, then you have to decide, okay, where do we migrate all of our data to? Where do we store the data, or all the new data we collect, where do we put them, right? So if you use Amazon, then S3 could be one choice, really good choice for data lake, right? So if you're running, for example, Kinesis Firehose, right, you can collect all the data in real time, and you just dump that into Kinesis Firehose. You can ingest that into Redshift, the databases or files, the storage systems, right? But there are companies who's running Hadoop in the cloud as well. So in the Amazon ecosystem, then it's the EMR cluster. So you can have a persistent or permanent EMR cluster running. But some companies will also just have transient clusters. They start and stop as the need comes. You'll need resource managers, right? So, in the big data world, if you're coming from Hadoop and Spark world, you probably know that Yarn is really important to serve a lot of the Java applications or projects. So Hadoop, is the resource managers is using Yarn in production. A lot of the Spark deployment is using Yarn as well. But again, the community are moving towards Kubernetes as well. I think one of the reasons why Hadoop is not doing very well is because companies are starting to embrace Kubernetes, so they have to catch up as well. So yeah, starting to hear some companies saying that they are Hadoop free and they run everything in Kubernetes. Now, let's say you have the resource manager set up and you have the storage, you have the infrastructure. The next step is, let's just, assuming that you have massive amounts of data, the data engineers wanted to process the big data, do all the transformations, right? There are many different ways to achieve the same goal here. But traditionally, companies will use things like MapReduce, right? And I'm going to tell you that MapReduce pretty much died, right? But in this ecosystem, if your company uses Hadoop, because Hadoop is not going to die, because HDFS is still going to be a very good, distributed storage system. There are always companies that are just going to use on-prem without moving to the cloud. Maybe they're trying to just completely moving to the cloud. But if you use on-prem services, then you have a Hadoop, then you're still going to need MapReduce. MapReduce has been improved, but you're definitely not going to write like Java MapReduce code. It's just not that easy and friendly to work with. So most of the companies are still going to use Hive because of the catalog or the metadata, right? So they run Spark on the same cluster and they need metadata, so which means they need the databases and tables and the views, and they will need summary statistics about those tables, and that's stored in Hive. And the companies have thousands of tables in Hive. They're probably not going to get rid of it if they have data stored in Hadoop, right? But Pig and Mahal, these are probably not really useful anymore. So yeah, so I think knowing Hive is still something worth to know, because you're not always just going to find a job that only focuses on Spark. There are a lot of companies out there, they definitely run Hadoop clusters, and using Hive. That's just a traditional way of dealing with big data, right? But the focus can be slightly different. You can focus more on the Spark side for data processing, okay? There are also some other tools that don't really rely on MapReduce, but they still work really well with Hadoop file systems such as HDFS and S3 or blob storage. These are Impala, Presto, and Kyling. Presto seems to be the winner right now. At least if Amazon is endorsing Presto, that means it's pretty good. I think it's probably more scalable than Impala. So I don't really hear about Impala that frequently anymore, but Presto is definitely doing well. And the company Starburst, behind Presto is also raised a lot of money. So I'm assuming that they're actually doing well. Kyling is the multidimensional OLAP tool in the Hadoop ecosystem, but it works with S3 as well. So if you want to build cubes, this could be one of the options, right? Okay, on the right-hand side, though, Spark is claimed to be this unified, right, analytics engine. It is pretty cool because you can use Spark to do MapReduce style, right, data crunching, distributed computing. It's based on the Spark core, which is called RDD. And the community added a data frame because a lot of data engineers and data scientists, they come from a Python background. They know Pandas data frame or data frame really well. And so they did a lot of optimization at the Spark data frame level, right, using the Catalyst optimizer. And on top of that, SQL is supported, Spark ML. You can use that to do structured streaming, which is real-time data processing in a micro batch fashion, and graph analytics. So and Spark is definitely something worth looking into if you want to become a data engineer. It's pretty hot in the market, and the company behind Apache Spark, it's open source, but the company behind Spark, Databricks, I think they're worth like 6 billion or 60 billion now. It's doing really, really well. It hasn't even gone public yet, and seems like a lot of the companies in Canada are actually, if they want to run Spark, they will use Databricks instead of Amazon EMR. So it's pretty user friendly, and there are a lot of cool features. They're building something called Delta Lake. So Delta Lake is something you probably need to look into as well. All right, so these are some of the skills and just a quick summary. Not going to spend time on MapReduce. but I just want to maybe briefly mention, distributed query engines. So let's say we're going to build some kind of dashboard, right? So your data is stored in your data lake. It could be Hadoop, it could be S3, but let's say we're talking about hundreds of terabytes of data. And traditionally, companies are going to use even more traditionally, companies are going to use, Oracle data warehouses, right? But we're talking about data lake. So you're using some sort of distributed computing engines, such as Apache Spark and Hive, right? So you're going to use Hive to run your daily and hourly batch jobs because the data is so massive. And sometimes you can run a query that takes, hours and even days to execute, right? So Hive is, the workhorse here. It's pretty stable when it comes to long running jobs that involves a lot of joins, billions and trillions of records. So heavy lifting stuff is done in Hadoop, MapReduce using Hive or Apache Spark, right? But so you're going to do a lot of filtering, aggregations, and joins. And at the end, you're going to have a much smaller version of the data, right, that you want to use for BI purpose. And then you can probably load the data into a relational database, right? Any kind of relational database. It could be just a relation. Aurora, it could be, MySQL. It could be sometimes even NoSQL databases, right? You can Snowflake. It doesn't matter. Any kind of databases, and Tableau, for example, or Superset, or you can use Power BI. They all have connectors to different databases, different sources, right? And then you build your dashboard. That's how things are done traditionally. And of course, you're going to have some latency. Makes sense for a lot of the businesses because your sales director probably don't need to see like an hourly update of the sales number. So they will look at the daily report, right? So you just need to have yesterday's sales data aggregated, right? So they don't really need real-time access to some dashboard. So in that case, I think this still works pretty well. But they're always like, maybe 10% of the time, or maybe slightly more, like 20% of the time, when companies actually just need more timely information. They don't want to wait for the daily update. They just want to know information right away. So in that case, you probably want to run, leverage some sort of interactive query engines, those MPP engines that can read from data from different sources, and these are distributed engines as well, so they can process massive amounts of data and run queries. Right, Facebook is open source Presto. They use this to run queries at petabyte scale, and Uber use Presto as well. Right, so and they allow you to query from the data lake directly and run some sort of MapReduce, and it's kind of, I would say it's closer to to Apache Spark because it has the lazy execution. But it's considered as a interactive query engine. So this is Amazon's Athena, right? And you can do federated queries as well, which is pretty cool. So if you need this kind of you want to refresh the queries more frequently, or even have lower latencies like seconds and minutes, you want to query the database or data lake directly, and you can use Presto for that. Okay, and Presto is pretty cool because if you look at the architecture, it has data connectors. So it's not really just built for Hadoop, right? You can read data from S3, from databases. I think it's called like federated queries in Athena, which means you can read. So like if you can join, let's say, a bunch of tables. And in a traditional data warehouse environment, if you're going to join tables, the data actually just sits in the same database environment, right? It's the same database engine. But with Presto, you can actually run queries to join 4 tables. And one table actually comes from a Cassandra NoSQL database. One data source comes from MySQL database, another table from Oracle, and maybe one table from Hadoop. Right, so it has this data connectors that allows it to read in parallel from it's a distributed engine, so it can read data in parallel from many different sources, which is pretty cool. So that's Presto. There's some competing products out there as well. Now, Apache Kylin is an extremely fast OLAP tool, but when I say it's fast, it's also cheating because it just pre-aggregates the data, and of course, the query is going to be a lot faster. But it's using MapReduce engine. It could be MapReduce or Apache Spark and Hive to aggregate data. Let's say you have like a fact table in retail database, and you have many dimensions, and you would like to aggregate I think eBay open sourced this, right? So if you have, I think when eBay runs a lot of the dashboard, they do have like a lot of dimensions because they will, you know, they have a typical retail, right? But they probably have a lot of product, you know, in their product catalogs. They have so many, like even millions of product and categories, right? So when they do aggregation, it's pretty, you know, heavy lifting computation. So they will use Spark and Hadoop to run those, you know, aggregations and joining tables, right? The fact to dimension. And the output, they call that cuboids. Those data will be saved in HBase, which is NoSQL database based on Hadoop HDFS. And the BI tools can just, you know, there's this, you know, NC, you know, SQL engine, Apache Connling that translates your SQL queries into the HBase API calls. And then you can use, so this is how you build your BI solutions on based on Connling. But the cool thing about Connling is that data can come from batch, but you can have data coming in real time from Kafka, and you can ingest that in. So it's sort of like just builds the cubes or update the cubes on the fly, which is pretty cool. So that's just another tool I think, you know, good to know. And from a data architecture perspective, this is how Uber runs their data infrastructure up till 2020. So they may have changed that already because, you know, tech firms evolve really fast in terms of data infrastructures. But it gives you a pretty good sense like what type of technologies you need to pick up. So on the data ingestion side, first of all, they have many different applications, right? Machine learning jobs, reporting. So I guess reporting is probably more like, you know, ad hoc queries. And they also have the business intelligence, which is more like a dashboards, right? And notebooks, machine learning stuff. On the left-hand side, data, right, are ingested into different sources. So you have data coming in, you know, data streams, right, from Kafka. Schemaless here just means, you know, NoSQL databases. But, yeah, of course, they have like, you know, relational databases as well. When you ingest data into the data lake, for example, data can be, so from Kafka Connect, right, save the data to Hadoop HDFS. Data can be saved from a NoSQL database into Hadoop using the connectors or using MapReduce and using Scoop. Right, Scoop is an open source project to bridge data between relational databases and Hadoop, right? So they have Hive. This is probably for catalog purpose, right? And Presto for ad hoc queries, and Apache Spark for ETL. But they still have a data warehouse, which means a lot of the heavy lifting stuff is done in Hadoop because they have petabyte scale data, right? So they may switch to Snowflake, who knows? But you know, at least, you know, on this, you know, diagram, you can see that a lot of the heavy lifting stuff is still, you know, eventually written, data is written to the warehouse. These are just, you know, relational databases that serve the needs for business intelligence and some other ad hoc queries. They do have streaming applications. So I think data engineers wanted to know, you know, stream data processing, right? Knowing Apache Flink or Spark Streaming will be helpful. Samza, I think it was open sourced at Yahoo. Similar, I think this product was open source just at, maybe it's at LinkedIn or at Uber themselves. I forgot, but yeah, so hopefully this gives you a good idea like what data engineers, you know, need to know. All right, so recommendations for someone who wants to learn data engineering and you know, practice the skill. I think it's important to it's, you know, for data scientists, I think if you want to get into the job market, you can build portfolio and you will say that, okay, I trained this machine learning model, and you have a Jupyter notebook, and people will be able to see your code. They'll be able to see, you know, the visualizations, you know, the dashboards you build. And even if you build a machine learning model, you can still visualize the results by doing model interpretation. And so a Jupyter notebook is very much interactive. It's kind of hard for data engineers to demo their skills, right? You can say, I know this, but like, how do you show it to people? So I think I would always recommend someone, you know, just understand, like data engineers, even though you're not an architect, I think you need to have those skills. You need to know how to just, you know, this is not a proper data architect diagram. But I think it would be great, if you know how to set things up on AWS, right, and just draw some diagrams to explain your data flows, or just visualize your data pipeline. Actually, just before COVID-19, there are a lot of interviews that will actually ask you to do the whiteboarding, right? So I think that would be useful. So you have a project committed to GitHub, but you want to tell people this is actually what I did, right? So you need to show people like, this is my data pipeline. I used Amazon EC2, for example, to run some Python script to collect data, and then I ingested data into Kinesis Firehose and Data Lens in S3. And then, I use Apache Spark, right, from Databricks or EMR to read data from S3, process the data, train machine learning model. You want to visualize that so people can easily, it just make, hiring managers, life easier, so they understand, the things actually you did. Yeah, knowing how to, well, I guess this is what I meant. So knowing how to draw this kind of diagrams or workflows, I think can be really helpful. So understand how to build things end to end, because if you want to build a data pipeline, the starting point is just like some data you collect from the web, or it could be data you collected, a bunch of table or CSV file, but you still need to load that into relational databases. Don't skip that part, right? And end of it could be a deployed machine learning model, automated, deployed using SageMaker, or could be a dashboard. And the dashboard is something people can actually see, right? So, okay, so I just summarized these top D skills you need to know, and I did that for different roles like, DA, DS, DE, and machine learning. Well, let's take a look at this first. So I think on the right-hand side, we'll see that Python is mentioned like, in most of the job postings, and SQL followed by Apache Spark. So definitely you need to know these skills, and followed by AWS. But whether it's AWS, Azure or GCP, it doesn't matter. I think you just pick one, and you want to make sure you get familiar with a bunch of, different services, right? The reason why Java is mentioned is that, as I mentioned, like, a lot of data engineer organizations has a stronger engineering, culture. So they probably use, Scala and Java, right, for their Hadoop applications, and Spark jobs, and Kafka, right? So on the data ingestion side, Kafka, and NoSQL databases, such as MongoDB, Cassandra. Yeah, looks like Redshift is mentioned here as well. But hopefully this is useful. This is the data engineering. But as you can see, for machine learning engineer jobs on the right, then you'll find TensorFlow, things like PyTorch, but also Python is really important. Not so much for SQL is not that important for ML engineers. And for data analytics, looks like, Tableau is really important. But recently, for some reason, there's so many jobs requiring Power BI and just surging in popularity. Definitely something you want to look into. Yeah, so these are